Activation functions. Activation functions in neural networks. AI beginner means intermediate level. Introduction. Neural networks learn patterns from data using layers of artificial neurons. Each neuron receives inputs, performs a calculation, and produces an output. However, if neurons only performed simple linear calculations, neural networks would be unable to learn complex patterns. This is where activation functions become important. Activation functions introduce nonlinearity into neural networks, allowing them to learn complicated relationships in data. Activation functions are used in many AI applications such as image recognition, speech recognition, language translation, recommendation systems, autonomous vehicles. Understanding activation functions is essential for learning neural networks and deep learning. What is an activation function? An activation function is a mathematical function applied to the output of a neuron. It determines whether the neuron should activate, send a signal forward, or not. In simple terms, activation function equals a function that decides how strongly a neuron should activate. Example concept. Neuron calculation means activation function means output signal. Activation functions help neural networks learn complex patterns instead of simple linear relationships. Why activation functions are important. Without activation functions, neural networks would behave like simple linear models. Linear models cannot capture complex patterns such as image features, speech signals, language structure, nonlinear relationships in data. Example concept. Input data means linear transformation means limited learning. Activation functions introduce nonlinearity, allowing neural networks to solve complex problems. Example concept. Input data means nonlinear activation means powerful pattern learning. This makes neural networks capable of learning highly complex data patterns. Where activation functions are used. Activation functions are applied inside each neuron after calculating the weighted sum. Neuron workflow. Inputs. Down pointing arrow. Multiply by weights. Down pointing arrow. Add bias. Down pointing arrow. Apply activation function. Down pointing arrow. Send output to next layer. Mathematically, the neuron operation can be represented as y equals f. Sum underscore I equals 1 caret n w underscore I x underscore I plus b, where x I equals inputs, w I equals weights, b equals bias, f equals activation function, y equals output. Types of activation functions. Several activation functions are commonly used in neural networks. Some of the most important include Sigmoid, Tanh, ReLU, Softmax. Each function has different properties and is suited for different tasks. Sigmoid activation function. The sigmoid function converts input values into a range between 0 and 1. Sigma x equals frac 1 plus e caret x. Example concept. Large negative input means output near 0. Large positive input means output near 1. Sigmoid is commonly used for binary classification problems. Probability outputs. Example. Spam probability equals 0.92. Tanh activation function. The Tanh hyperbolic tangent function outputs values between -1 and 1. Tanh x equals frac e caret x plus e caret x. Example concept. Negative input means negative output. Positive input means positive output. Tanh is often used in hidden layers of neural networks. Recurrent neural networks. ReLU, rectified linear unit. The ReLU function is one of the most widely used activation functions in deep learning. F x equals max 0 x. Example concept. Negative input means output equals 0. Positive input means output equals input. Advantages of ReLU. Simple and fast. Reduces computation cost. Works well in deep neural networks. ReLU is commonly used in hidden layers of deep learning models. Softmax activation function. The Softmax function is commonly used in the output layer for multi-class classification. It converts outputs into probabilities that sum to 1. Example concept. Image classification probabilities. Cat means 0.70. Dog means 0.20. Rabbit means 0.10. Softmax helps the model decide which class is most likely. Activation function workflow. The process involving activation functions looks like this. Input data. Down pointing arrow. Weighted sum. Down pointing arrow. Activation function applied. Down pointing arrow. Neuron output. Down pointing arrow. Next layer processing. This process happens for every neuron in the network. Real-world applications. Activation functions help neural networks solve complex problems. Computer vision. Detecting objects in images. Speech recognition. Converting speech to text. Natural language processing. Understanding and generating text. Healthcare AI. Detecting diseases from medical data. Recommendation systems. Suggesting movies, products, or music. Advantages of activation functions. Activation functions provide several benefits. Advantages include: enable nonlinear learning, improve neural network performance, allow deep neural networks to function, help models learn complex patterns. Example concept. Activation functions means powerful AI learning capability. Limitations and challenges. Activation functions also have some challenges. Limitations include: vanishing gradient problem, especially sigmoid, dying ReLU problem. Selecting the right activation function can affect performance. Example concept. Poor activation choice means slower learning. Careful selection improves neural network training. Concepts learned from activation functions. Understanding activation functions helps learners understand. Checkmark how neurons decide whether to activate. Checkmark how neural networks learn nonlinear relationships. Checkmark why deep learning models work effectively. Checkmark how neural network training improves performance. Checkmark how AI systems process complex data. Activation functions are a critical component of neural networks and deep learning models. Simple definition. Activation function. A mathematical function used in neural networks to determine whether a neuron should activate and how strongly it should pass its signal forward. Final summary. Activation functions play a critical role in neural networks. They transform the output of neurons and introduce nonlinearity into the model. Without activation functions, neural networks would behave like simple linear models and could not learn complex patterns. Common activation functions such as Sigmoid, Tanh, ReLU, and Softmax help neural networks perform tasks such as image recognition, speech processing, and language understanding. Understanding activation functions is essential for mastering neural networks and deep learning.